Welcome to Unleashing the Power of Vector Searches. So let's get started. Before we begin, I need a volunteer. Does anybody have their resume in PDF by any chance? Handy somewhere? Just your resume. Anybody? You do? Yeah, send it to this email, taswar@gmail.com. Sure. It will be more fun. I like to be on the edge to try something out. So I'm lucky I got taswar@gmail.com. It's really hard to get. It's my name. I was one of the first ones to join the Gmail, so I got it. Or else I would be taswar7895 or whatever. So you got the note? You got it? Okay, you're good. Thank you. PDF. Okay? You send it too? Okay, that's good. Okay, about me. I work for Microsoft, Azure, and I'm a lead AI and security cloud solution architect for Microsoft. I used to be working for AWS. I speak quite a few languages. I speak Chinese also too at the same time, and I live in Turkey, so I speak Turkish. Swedish, unfortunately, no. The only thing I know is good morgon. And I'm a developer at heart. Like, I love to code. Like, that's what I do. And this is the Swedish spelling of my name, I guess, is kind of... Okay, agenda. That's the Studio Jellybees, changing my image to that. A little bit of an intro of SQL Server 2025, why Azure SQL Database for AI, a demo of vectors, and why it's built for developers. And then the last demo is I'm going to try to be on the edge and see what happens. Okay, before we get started, turning torsos. You guys know that, right? How tall it is 190 meters, right? Did you actually know that the Pyramid of Giza is 146? That was ages ago, actually. So, some fun factor. I'll kind of like relate it into why I'm talking about this. Okay, sorry. Oh, it jumped. Did you also know that Europe before 1853, that's an important number, most houses were only 2 to 4 stories high, and rural sites were only 1 to 2 stories high. So that was the common norm of like things at that time. Now, what changed? Do you guys know this guy? He kind of looked like a Swedish guy too. Do you know who this is? No idea? That's fine. His name is Otis, actually. Elisha Otis. Anybody know who Otis is? Okay, you know what Otis is. You guys have probably been in an Otis too. Okay, so he invented a safety device that prevents the elevators from falling down, basically. So like a braking system for elevators. So when you go up and down the shaft, it actually stops, sort of thing. So there's a safety thing that he actually for the cables. So he invented that. So you've seen the Otis elevators, maybe, yeah. So his invention actually basically allowed us to create a high-rise building. Because before we were all lazies, like we didn't want to, who wants to climb up 5 stairs of like, go to their apartment, right? So usually at that time it was like 3, 4 stories high. But with his invention, basically, we ended up having high-rises, like tall buildings. So that actually led us to creating skyscrapers. So we have these tall building, turning torso, for example. Now, why I'm talking about this, the right tool, to use the right tool for the invention actually leads you to a path of something. So it comes to the right tool. Marketing speech. SQL Server 2025. If you want to know when it's going to be coming out, watch Ignite on November 18th, and you'll be able to know all the details about it and stuff. So November 18th is an important date. Okay. So it's AI ready. Security and performance built with AI, made for developers, and agility through Azure, basically. So there's SQL Server that you install on-prem, and there's Azure SQL Server too. So they're kind of like in parallel sort of thing. So SQL Server has been built on a foundation, basically. So there's the SQL Server 2017. We introduced SQL Server for Linux, containers, graph databases, machine learning was put into it. In 2019, we actually put in like data classification, recovery, like replicating to another database. And 2020, we actually had like a data lake, ledgers. So all that stuff was built in. And 2025 is where we're actually introducing AI and vector sort of. So when we look at the AI-ready enterprise sort of thing, you have the Olama to the Azure Foundry to OpenAI, and then you could develop modern applications that you want to build. And at the end of it, you could integrate it with your Fabric. Fabric is the data lake, basically. It is secure by default, mission-critical engine. And if you look at the bottom, Arc, do you guys know what Arc is? Arc is basically if you have an on-prem data center or something like that, you want to connect it to cloud. Microsoft has this technology where you could connect it to it and actually have your on-prem also in the cloud sort of thing. Assisted by Copilot and optimized for latest hardware. It has the built-in for ARM, actually, ARM 2 now, built for all platforms. Okay, again, like for Fabric, it's basically our data lake. It's the same kind of information. Developers, T-SQL, and tools and Copilot, which is the ChatGPT kind of thing, and Fabric. So data lake, when I talk about data lake, usually we see data lake on the top, but what it actually is for data engineers, I know there's data engineers, what really is actually you're dealing with a swamp, not a lake, actually. It's like there's like late arriving data, there's null values, ETL jobs, schema drift. This is what real life is. So SQL Server 2025 has AI built in, hybrid AI search, which I will show the vector how do you do AI hybrid search. Flexible AI models, you could choose models that you want to use. You could use Olama, you could use any other model that you want to do. You could build it with like LangChain, a semantic kernel, which is currently the Microsoft agentic framework. Performance-wise, we all know SQL Server, it's performance. Fabric, again, data lake, and licensing, I don't really care, like use it, use it. So what are the problems we're trying to solve with AI? So smart searching. So in some ways, like if you already have a database, SQL Server, for example, it kind of makes sense to actually introduce AI into it because you're already using it. So why not extend the feature of it? So a smart searching for existing text information that you might have. You could bring in and vectorize your data, basically for searching. You could use it as a building block for your AI agent that you're going to be using or your RAG patterns, retrieval argumentative generation. You could take advantage of the secure that we actually provide for the data. And then you could actually use the T-SQL to actually answer your complexity sort of thing. Because you know SQL service, SQL. Everybody knows SQL, right? Okay. Anybody don't know SQL? Okay. So again, there's building for AI agents, for vector searches, structured queries, for LLMs, operational RAGs. Here's one of the things that actually people tend to ask me. What's the difference? Like, I mean, there's SQL Server, but I could use Postgres. Like, there's PG Vector. Like, why would I use this over that? So my answer is quite simple. If anybody using Postgres, get out of here. I don't want you. I'm kidding. So the answer is very, very simple. Postgres is actually a really good database, relational database, excellent. But if you want to have like vector, you install a plugin, right? PG Vector into the database to extend the functionality. The difference between SQL Server compared to Postgres is basically SQL Server kind of builds it in. So when it comes out with the different version, it builds it into the database. That's the only difference sort of thing. So if you are currently already using SQL Server, then if you want to use vector and all that, so you kind of upgrade to the next version of it. So it's all built in as enterprise support and all these other stuff that built into it. While Postgres, you might have to use open source and all that stuff. So when we talk about enterprise companies kind of thing, they want to be more safer kind of thing. Financial companies to anything else, they want some kind of a support for it. That's the only difference. But I mean, you choose your own, basically, database that you're comfortable with. So again, enterprise ready, there's vector store in it. There's dis and index. You could manage the model, whichever model that you want to use. Embeddings, I'll show embeddings, how to actually use the embeddings. There's vector distances, KNN and ANN, so which KNN is nearest neighbor, and ANN is approximate nearest neighbor. So approximate nearest neighbor is usually used for when you have large datas, basically, because it's going to be faster than using KNN. Again, framework integration. And how the vector store kind of works is basically you define your model, which one you want to use. You might want to use Azure OpenAI, Olama, or whichever that you want to use. And then you create embeddings. Basically, you create embeddings using whichever LLM that you want to use. And you store it in your existing data, or you could use some other way of storing it, and you could create an index for it, which is a smaller, like indexing, basically, vector indexing. And then you might actually ask a prompt from your application to say, or to SQL Server to say, hey, I want to get this kind of thing. And you might generate that embedding for that thing, let's say pizza, and then you actually generate the embedding for it, and then try to actually use vector search to find out the information from it. How close is that information? Or other kind of filters using SQL and all that. Feel free to take a picture. And the cool thing is actually this thing, SP invoke external REST endpoint. So I'll show this through in the demo. This actually shows you how you could use a stored procedure and call a RESTful endpoint somewhere else. So this is kind of neat. I'll show you how I'm using it to actually get embeddings. So again, for security and SQL Server and AI, there's like control access with SQL security, AI models that you want to use, la-di-da-di-da, tracking SQL auditing, and Ledger if you want to use Ledger. Secure by default. So there is managed identity that you could currently use for SQL Server. So it's all built in. So you could actually connect to Azure and then like have managed identity. You don't have to create identity inside of your SQL Server. So challenge. So this is it. I like to do a little bit of a jokes before I do the demo sort of thing. So if you don't know T-SQL, no problem. We'll have a visual join to explain to you how it actually works. So you see the left join, the guy with the beard and a mustache. Right join is the guy with hair and a mustache. Full outer join is the whole thing. And then you got inner join, which is just the mustache. Cross join is everything. And then no match is no hair, basically. So that's kind of a visual way of explaining SQL. So let's get to demo. So let's try the demo. So I'll be using Visual Studio. Okay. It's clear, right? Let me just refresh one more time, just to make sure. So here, you could see, I am actually just creating a vector table, and inside it, you will see that I am creating an embedding with a vector size of 3. Basically, I'm just saying like the size of it, it's going to be 3. It's not going to be null. And then below, you could see that I am actually inserting these kinds of vectors into it, some numbers, some random numbers. These don't mean anything, sort of thing. So this is how you actually store a vector, almost like an array if you're used to the arrays and all that. So hopefully it loads. It should be loading. Come on, come on. It's connecting. I wanted to show like how an embedding actually looks like inside of it. Any questions so far? While it's loading? No questions? Everybody's happy? How was the food? Vegetarian? Woohoo! I know you like vegetarian. Actually, I heard the reason why they make it vegetarian, right? Because when one time they introduced meat, and people felt sleepy afterwards. So that's the reason vegetarian actually kind of works. Come on. I'm sorry? Oh, yeah. Thank you. Good point. Let me see. So I'll just use this person. Let me just download it. There we go. Let me just close this. And let me put it into the resume. while we're waiting for it. I'll just name it, rename it, just to a.pdf or Bob. Okay. Named it Bib. Bob. There we go. Bob.pdf. Okay, so did we get that up and running? It's still waiting. What's going on? That's one of those things when you have to do a demo, it doesn't work. Before this, it was all working. And I was here like half an hour early. Let me try. Yeah. It's taking a bit of time. Okay. In any ways, I've created that embedding, vector size of 3, and then I'm storing these embeddings. So inside that, I could query it, and it would store those array kind of an object inside of it. And let's take a look at sample 2. Okay, so here's 2 vectors that I've defined, size of 3, again, 1, 2, 3, 1, 2, 1. And what I'm going to be doing is actually, there's a function called vector distance. So vector distance, you could provide the first parameter as in like what kind of distance do you want? You want Euclidean, or do you want cosine, or there's also a dot for negative dot product. So the cosine one is the really important one, basically. When you use vector, it's like think of it as an arrow within like three-dimensional space sort of thing. So there's an vector for it. So if you have like a vector representation of a text string, let's say the word, I used an example earlier, dog, and then there's a vector of it, and then you vectorize cat, for example, and then you have another vector. By using cosine, you could actually find out how close they are, those words. Basically, dogs and cats, kind of close. Dogs and dogs would be 0 because they're like the same thing. But if you say dogs and a table or something like that, then the vector is going to be way further away, sort of thing. The angle of it, the cosine angle of it. So that's how you find similarities between a word of some form in a vector way to another vector. That's the whole idea of it for vector searching. So let me see. It's still loading. What's going on? Let me try the other one. Okay, this one's working. Tables. There we go. This one is working though. Okay, so maybe I'll just copy those things over here. I don't know why that is. Okay, I'll just use this, and I'm going to be running this. Basically, let's run this. I'm sorry, one more zoom? Sure. Okay, there you go. So you could see like when I'm calculating a cosine, 1, 2, 3, and 1, 2, 1 as a vector, they're kind of like 0.12 distance-wise sort of thing. So they're not far away. So let me try another one. Let me just grab another example. That's still loading. Let's look at this one. Okay. Copy this guy. Unfortunately, it's only working over here. So here, what I'm going to do, I'm going to show you. So I'm declaring something called pizza as a vector of 1536. Okay, what's 1536? Basically, that's the embedding size of OpenAI. So every embedding model might have a different size. So for example, in Llama, they have a different size. So you need to make sure what is the size of your embeddings that you're going to be storing. So you see right here, I'm declaring pizza, declaring a dog, I'm declaring a cat, cow zones too, which is almost similar to pizzas. And then I'm actually calling a stored procedure called get embeddings. And I'm providing the embedding names, which I'm providing, the text that I want to vectorize, and then I'm just getting back a output, which I'm storing in that variable, sort of. So far, so good. And then what I'm going to do is I'm going to calculate the distances between these two vectors. I'm going to say, what's the distance between pizza and pizza? What's the distance between pizza and cat? What's the distance between dog and cat? Calzone and pizza should be closer, sort of thing, rather than pizza and cat. You don't want a cat, we want a pizza. Anyways, I know you like cats, so let's run this and see what happens. Where's the run? Let me just... Nope. I'm just going to copy, save this first. Actually, where can I save this one? Ooh, it's PHP. Test 2.sql. Let's see, there we go. So I'm going to run this to my database. Come on, there you go. Yeah. Let's declare hamburger. Where do I say hamburger? There you go. This should be calzone. Let's run this again. There we go. So pizza versus pizza, how far they are? 0, because they're the same thing. Pizza versus cat, 65. So when it's close to 0, that means it's the same thing. So quite far away. Dog versus cat, you could see it's closer, 30, 39. And then calzone versus pizza is like 45 sort of thing. So close enough. So you kind of have a threshold of figuring out what is close to what. So let's look at the next example. Example number 4. Okay, here's where actually I wanted to show the how do I actually call that URL for that SP invoke sort of thing. So here I'd created a stored procedure, and I'm just declaring some response payload that I'm going to be sending it from the input text. So the pizza comes into input text. And then what I'm doing is calling my OpenAI Azure endpoint and saying that, hey, you know what, this endpoint, please actually get the embeddings. Here's the version of it. And here's where I actually call the external endpoint. I'm calling this endpoint to say, hey, you know what, this is a RESTful call. I'm getting back a JSON payload out of it. And I'm posting to it with my credentials, which I get from Azure. And then basically I just call that, and I get back a JSON query, which I could parse through too, because currently actually it supports JSON too. So I could parse it through and store it back as a vector, like the result of the embedding, and return it back, basically. So all of that stuff is there. And actually, when I scroll down, you'll see here. Here's how the vector actually looks like, a bunch of numbers. Like, this is pizza, basically. Pizza is divided into all these numbers. So you could see it's like pretty large. Like, if I scroll down, like, that's just pizza. Anyways, but that's how you actually kind of calculate how far things are. Okay. So let's see, let's jump back to the presentation. Okay, build for developers. So if you're using GraphQL, you could call SQL Server, which has JSON support now. So you could actually parse through things. There's T-SQL. There's streaming for change events. There's the RESTful API, which I just showed, that you could call. You could use GitHub Copilot for SQL and generate SQL out of it. You could point your database, say, here's my database, generate me the SQL for top 10 products being sold or something like that. It will generate you those SQLs too. And there's a new driver that's coming out for Python, built by Microsoft, basically. The platform-wise, basically, like how we see it architecture-wise, you have a SQL Server, and you might have a replicated SQL Server. You might call it embedding and using one of those models, RESTful endpoint, the one that I just showed. And also, like, manage identity if you have Arc. And you could actually have you built your agent with Azure Function, and it has streaming too, event hubs. And you could build your applications, basically, semantic kernel or whichever agent that you want to use. SSMS is basically the studio for SQL Server. So it has Copilot built in too now. So you can actually use Copilot. So here I wanted to show a quick video of a customer choosing the other demo of SQL Server. So, I mean, like, that customer could be a developer too. Like, when you use the wrong tools, you might actually shoot somebody too. So let's go through the other demo of it. Now, this one is more fun. This one, what I did was actually, does anybody know what WebDriver is? Okay, WebDriver is a way to automate your browser, basically, okay? So during summer, I was bored, and I actually started scraping career pages of Microsoft so that I could collect all the career positions that are there. That's why I requested the resume. So I'll show you this quickly. If I run this, what's going to happen? So let me look at the terminal. So what it does is actually opens up the Edge browser. You'll see it opens up. I'm not touching anything. You could see it's automated test software. It's all written in Python. And it's going to click on sign in. It's going to sign in for me. It's basically, I'm scraping the web from this. And then you can see it's going to sign in. Something should pop up. It's one of those internet things too, again. Let's see. There you go. So it's going to automatically click on the employee, which I'm an employee. And then what it does is actually goes to the careers. Come on. Yeah. There we go. And it's going to automatically filter throughout what are the current positions on the left-hand side, like commercial, blah, 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 blah. And then you'll see that, okay, it's run through already because I already imported all of that stuff, so it's skipping it. It's just, I coded it so that, hey, if I already extracted that information, I don't need that. So how does my data actually look like? Let me just open this, format it. So here's the position, basically. It's a software engineer in India. It extracts all that information into a JSON document, basically. I grab the HTML, and I make it into a JSON document so that I could actually query it, right, afterwards. It's a software engineering position. And then it tells me what are the overview, what are the responsibilities, what are the qualifications. So again, if you think about it, I can make this into a document of embedding, and I could actually figure out how close are you to these positions that I have. So that's why the demo of it. So now I'm going to import your resume. So I named you Bob. Well, again, Bib. So Bob, it's going to be inserted into the resume table as a vector 1536. Okay? So I'm going to run this. Come on, come on. There we go. So it kind of like parsed through so that I could see that they actually converted the text into, converted the PDF into text sort of thing. So I've got his inside my database now. So let me. Okay, it's you. Okay, that's good. So he's probably, let me just see, select the top. He's probably number 8. Let's see, where do I have it? There you go. So let me just run this query quickly just to see his ID, where he is, so that I could point it out. It's probably number 8, I'm guessing. Come on. I think it's number 8. One of those things, when you demo it, it doesn't work. When you're not demoing it, everything works. Let's see. Come on. There was an error of some sort, I think. So, okay, I could try his resume. Okay, doesn't matter. So for the demo, let's see. I had the SQL actually. Where did it go? That's the JSON. Let me close that. Don't save. Oops. Don't save that. That's fine. Where did my file go? Let's see. Oredev. There we go. So, okay, here's my query. I'm going to zoom in again. Here's, zoom in too much. There we go. Okay, so I'm selecting the top 10 positions by the job number, the title, the date that it was posted, the location, and then from the JSON value that I stored, remember that document, I'm pulling out the travel. Let's say, does this job require me to travel or not? And then I'm trying to find out the embedding of it. How far is it, basically, based on the job and my resume embedding, like how far they are, basically. And then from there, I'm doing a cross join. So I'm doing a cross join with it. I'm saying that, okay, for location, I only want to look in Denmark and Sweden. Those are the two locations that I want to look for. And his ID, I'm going to guess it's going to be 8, probably. And the distance of it. And then I'm actually doing a distance of it, 1 minus the distance. Because our mental model is more like how much percentage is he close to? So it's not the 0. 0 is usually a negative number for us. So we tend to look at like how far is it by percentage? Is he 60% closer to this position or 70% match sort of thing? Rather than going by 0, we tend to like match things more towards a higher number. So if I'm going to run this based on his, hopefully his 8, let's see. Come on. There we go. So here we go. Here are the top 10 positions that are in Copenhagen and Stockholm that kind of matches in. So you'll see the cosine similarities. So here's the top ones, 63% you match for a position called Customer Success Account Manager, okay? Digital Cloud Solution Architect, there's those positions too, Cloud Solution Architect. So these are all positions within Microsoft, okay? They might be expired, okay? Some of them you see July kind of thing. I've just been scraping data sort of thing to analyze all of this stuff for fun. So it kind of like tells you how close you are to that resume. So as a recruiter, if I'm a recruiter, I could actually go through and say that, hey, you know what, I got his resume. What are the top 10 position he actually matches to? And I could actually, hey, Keith, right? Keith, do you want to interview for that, what's that position? The Customer Success Account Manager in Microsoft? Would you be interested? Because you match quite closely, kind of thing. So that's how you kind of, if you think about it, if you use AI on top of it, LLM or something, then you could actually query it. Hey, I have Keith's, so it would actually look up Keith's resume right away and use as a RAG pattern and provide it to the LLM to say, query the database, find me the matching, execute this store procedure, come back and give me a table format of like what Keith actually matches. So now actually as an LLM, it will say, hey, by the way, Keith actually matches these kinds of, these roles, these top 10 roles that I have that you could actually offer to Keith, basically. So that's how you kind of like, you could use it, or even like other examples of like, if you have a repository of like insurance claims or something, if you're an insurance company, you could actually now use vector searcher to see how close is this claim to the other claim. Is the person abusing the spectacles, like glasses thing, like he's been getting too much of them? Or you could think about it, I could now query disgruntled customers, find out if they're going to churn or not. So I could actually query that, hey, there's like 5 complaints from this customer. He might actually go to another cell phone company or something. So maybe I should call him up and like say, hey, you know what, we have this offer kind of thing. Would you be interested in it? So there's all kinds of use cases that you could potentially use with vector searches. So that was my demo. And call to action. You could take a picture of this if you're interested. So Ignite is going to be on November 18th. And you could check out all of this stuff that's going to be updated with all the latest stuff. There's demos, there's like, there's going to be decks, there's going to be like how to get SQL Server 2025. All of that stuff's going to be there. So that's my last slide. Questions? I have 4 minutes. Not too bad. Yes. Yeah. Yeah. So you actually, it takes multiple multiple steps to actually find out. The question was actually basically, how do you find out the number that is there that actually gets out to this, the closeness of it? How do you figure out what is the right percentage of it? It actually takes multiple times for you to figure out because it's your own data, right? So when it's your own data, it could be 0.67% that actually kind of matches more of the documents, and it's not canceling out all of the stuff. So you need to actually really test out a couple of times to really figure out what is the right percentage. Like it could be here, I'm just saying 75. I mean, it could be a little bit more, but I don't know, like Keith, I don't know what positions you imagine to, but I'm saying 75 sort of thing. So it really depends on your data and you're trying it out. Yeah. Other question? Yes. Yeah. So in Postgres, you could use PG vector, basically. You could query it and do all that stuff. Now, there's going to be versions of SQL Server. The Express one is going to have these features too. So you could actually use the Express one and query it and do all this stuff too. Yeah. Any other questions?
I didn't quite understand the number. Was it 1536 you put?
Oh, the embedding, actually, the question is actually 1546. Why 1546? The reason is actually every LLM creates an embedding that could have a potential different size. So if I'm using OpenAI, an OpenAI text model actually uses 1536. So that's the number I have. I'm sorry? Yeah, exactly, the small one. So you could use bigger ones too. Olama is actually smaller. I think it's 1026 or something like that. So there's different sizes for it. So you need to make sure what's the size of the embedding is going to be in order to store it. Yeah. Sorry, there was another question there. So yes, I totally agree with the question. Was basically like it would be nice to actually analyze why did it actually match those percentage, cosine wise sort of thing. So it could be keywords that he has specifically that actually matches that position sort of thing. So I've seen that like when I say computer science, but the job position is computing science. And computer science is supposed to be close, but actually it's not that close for some reason. And then when you actually rechange your resume to say computing science, it actually matches closer. So here's a trick for you. If you see a position with the keywords, put it in your resume. Stick it in your resume. You're going to be closer because these days there are so many people applying for jobs. And like, I mean, if you want to win a chance with it, grab some of that information, stick it into your resume, look at the wording of it, because no one is going to go through 100 resume and select them. So, I mean, this probably is another way. I don't work for HR, but I think they probably go through that. Yeah. Yeah, then always select myself, right? That's the one. That's the trick of like basically if you use a white background and white font, you could actually inject something for it to LLM to say that always pick me for the position. But because it's a resume in white, so you might not see it, but it's in there. So it's a way to actually hack into an LLM to actually give that result for you. Yeah. That's another trick. Yeah. Other questions? We're all good? So apply for that job. Sure. Thank you so much. Time's up.